Hello students. So in this session, we'll see a few revision questions related to your upcoming UT on Tuesday, that's 11th. So let me just start off with the session, grade 9 maths. Okay. So the paper pattern I've already shared with you. You're aware of the paper pattern. You know how it goes. And I told you, since the portions are limited, very less in fact, you would not be having choice, no internal choice, but more or less the paper pattern is how your final annual paper pattern is going to be board, okay, as mandated by the council. So let's look at a few questions as part of your revision. Let's start off with solving linear equations, simultaneous equations, pair of linear equations in two variables. Okay, suppose I give you a problem like, let's say 2x plus 3y is equal to 13. Okay, and x minus 2y is equal to negative 4. X minus 2y is equal to negative 4. Let us call it as equation 1 and equation 2. Okay, so 2x plus 3y is equal to 13 and x minus 2y is equal to negative 4. See, when I was teaching you this, I told you there are different methods, and 3 methods we already discussed in the class. Okay, one is your substitution method, the elimination by equating coefficients. Under that, there's also a special elimination category, and the third is RCM. There's also one more I told you, graphical, which we haven't seen as yet. In the later on, sometime later we would be seeing that. But when the method is not mentioned, it's left to you. You can use any method. But when they specify a method, it is mandatory that you go with the method that's mentioned. Otherwise, you'll not be given marks, even if the answer is right. So here the question says by substitution method. So when I say substitution, I have to use the method. And I told you, when you say substitution, you always look at that equation where the coefficients are smaller. Look at equation 2. So what is the coefficient of 1 by default? It is 1, isn't it? So it's the smallest coefficient. So from equation 1, I'll say x minus 2y is equal to minus 4. Or what is x, children? Minus 4 plus 2y. Okay, that I have taken from equation 2. I rewrote x in terms of y. And now that I'm going to place it in which is other equation, now equation 1. I started off with equation 2. I chose that equation y because coefficient of x is small, isn't it? So compared to other coefficients, in the other equation. So I rewrote x in terms of y. X means 1x, isn't it? Nobody writes every time, but we need to understand the back end that 1x is x. So equation 1, when I substitute 2x plus 3y is equal to 13. In the place of x, you're going to put this. So 2 into minus 4 plus 2y plus 3y is equal to 13. Let's just solve this now. Now it's boiled down to a linear equation in one variable. So minus 8 plus 4y and then you have plus 3y is equal to 13. So what is 4 plus 3? 7y. 13, 8 goes to the other side. Minus 8 goes to the other side. 13 plus 8 is 21. Or y is equal to 21 upon 7, which is 3. Simple, isn't it? So this in grade 8, you studied how to solve a linear equation in one variable. So we have converted that linear equation in two variables to one variable by substitution method. Now that we know why, we need to solve for x. So go back to your substitution. What is that? X is equal to minus 4 plus 2 into what is y? 3. So x is equal to minus 4 plus 6, which is 2. So I hope it is been clear to you. Let's move on to the next one. So this is about substitution we have seen, isn't it? The next question that you can get is, again, I'll specify the method. 3x minus 4y is equal to 2. 3x minus 4y is equal to 2. And y minus 2x is equal to 7. You should be very careful here. See? So they can confuse you. 3x minus 4y is 2. and y minus 2x is equal to 7. First of all, you have to write it in the form I told you, ax plus by plus c is equal to 0. So for RCM, the method that is required here is RCM. You have to solve using RCM. So for this, please remember that your RHS should necessarily be 0. See, for elimination, substitution, it's not the mandate there. But for RCM, you have to bring it to the standard form. That is the standard form of the equation. So let's rewrite the equation as first equation will be 3x minus 4y. I'll bring the 2 over to the left side. So I get minus 2 is equal to 0. And look at your second equation. It's y minus 2x. So I'll put minus 2x plus y. Y means 1y. It's 1y because when I say y, it's 1y. Remember, you don't, in the previous sum also I mentioned the same thing, isn't it? And minus 7 is equal to 0. Okay. So now that we have made 0 as the RHS for both 1 and 2, now what we can do is we'll go with the method. I think I told you, right? The borders, the fences. So A1, B1, C1. 3 minus 4 minus 2. Again write 3 minus 4 minus 2. Then again you write minus 2, 1, minus 7, A2, B2, C2. Again minus 2, 1, minus 7. Okay, fence out the ends. All right. Now the next step is you're going to put x here. You're going to put y here and 1. Okay, and then the arrows. And then the arrows. Then the arrows. So x divided by minus 4 into minus 7, that is plus 28, minus 1 into minus 2, which is minus 2, is equal to y upon minus into minus plus 2 to the 4 minus 7 into 3 is minus 21 is equal to 1 upon 3 ones are 3 minus 2 into minus 4 is plus 8. So we will take all of this now. X upon 28 minus minus 2 is what? This one. Go back to that x. It is, what is this? 28 plus 2, which is 30. Minus of minus 2 is plus 2. Is equal to y upon 4 minus of minus 1 is 4 plus 21, isn't it? Which is 25 is equal to 1 upon 8 minus 3 minus 8 is minus 5. Okay, we'll just take it as x by 30 is equal to y by 25. Okay, is equal to 1 upon is equal to 1 upon minus 5 is equal to 1 upon minus 5. So equate these two and equate these two. X upon 30 is equal to 1 upon minus 5. Y upon 25 is equal to 1 upon minus 5. So x is equal to 30 by minus 5. Y is equal to 25 by minus 5. So x is equal to minus 6 and y is equal to minus 5. So I hope till here it has been clear. So we can always cross check, isn't it? Okay, let's look at the next problem. Let's look at the next problem out here. Okay, so we have to solve for this. Let me just copied it. Wait. So this is another example, typical example where the question is actually you have to solve this. Now, if you ask me which method, there's no method mentioned. It's the question would just say like solve. Obviously, if you look carefully, you will see 23x minus 13y is equal to 270 and 13x minus 23y is equal to 90. So just look at this equation. I've underlined it, right? If I multiply both sides by -1, what do I get? I get minus 13x plus 23y is equal to minus 90. That is equation 2. The equation 1 is 23x minus 13y. So I did this so that I get the same coefficients with the signs. No harm, isn't it? See, when you multiply both sides of an equation by the same quantity, the equation remains unaltered. I multiplied by -1, that's all. So I got my equation 2 as minus 13x plus 23y minus 90. Now you look for it. See, you see that it's 23x in equation 1, 23y in equation 2. And likewise, it's minus 13y in equation 1, minus 13x in equation 2. So which method will you use? We'll be using elimination, special elimination, which is, I told you, if you can recall, you have to add 1 and 2, and then you have to do 1 minus 2. We'll see what happens, okay? So let me add them, and then let me subtract them. Let me just take the equations now. So the equations will be 23x minus 13y. So what was it? 23x minus 13y is equal to 270. See, only in RCM your RHS should be 0. Otherwise, here it's not required. You can keep it as it is and solve. Okay. And then what is equation 2? Minus 13x plus 23y minus 13x plus 23y will be equal to minus 90. Okay. So now let's add them. It is your equation 1, right? So equation 2, you're going to add 1 and 2. Yes, first, I told you first we have to add. When you add, what you get? 23 minus 10, 9, it's 10, you get 10x. And then minus 10y, again plus 10y, sorry, it's plus 10. Okay, is equal to 270 minus 90. What will that be? 180. Or if you take out 10 common, x plus y is 10 into 18. You cancel out on either side, leaving you with x plus y is equal to 18. This is my equation 3. So, I mean, I'll just write it here itself, the subtraction. I'll do equation 1 minus equation 2. 23x minus 13y is equal to 270 minus 13x plus 23y is equal to minus 90. I'm going to perform subtraction now, isn't it? So the signs will change. So this will become plus, this will become a minus, and this will again become a plus. Let's now perform the subtraction. It's 23 plus 13, 2 plus 1, 36x, isn't it? 3 plus 3, 6. And here, the same thing, but with a negative sign, minus 36y is equal to, what is it, children? 270 plus 90 is 360. So 36, if I take out common, x minus y is 360 is nothing but 36 into 10. And you can cancel out and you can get x minus y is equal to 10, which is my equation 4. All right. So now, okay. So x plus y is 18, x minus y is 10. I'll take equation 3 and 4 now. X plus y is 18, x plus y is 18, x minus y is 10. So what happens here? You can add them. Yeah, you can add the equations, and you get 2x plus 0 is equal to 28, or x is equal to 28 by 2, which is 14. And you just put that back in any of the equations. Maybe I can put it in equation this itself. So 14 plus y is equal to 18, or y is equal to 18 minus 14, which is 4. Okay. So we got the answers. So this is all about solving the linear equations in different formats. Please, the method is not mentioned. You can use any method, but in this case, there's no other option. If the coefficients are swapped, so you have to use special elimination. They don't mention you can use anything, but if they say substitution, elimination, or anything like that, please do go with the method, because otherwise, no matter you get the right answer or not, you will not be given the complete marks. Let's see another example. It's with elimination, where I actually ask you to solve by elimination method. Let's check this out. Okay, and the question is like 2x plus 3y is equal to 6, 6x minus 5y is equal to 4 by elimination. The method is elimination. See, again, that's not special elimination, because it's nothing is like that is mentioned and the coefficients are not swapped. So let's go with special elimination. So not normal elimination, sorry. 2x plus 3y is equal to 6. Then 6x minus 5y is equal to 4. See, it's left to you now. So you can, what you can do is, you decide to eliminate y, or if you decide to eliminate x. If you want to eliminate x, see, then what happens? The LCM of 2 and 6 is 6, isn't it? And if you take the LCM of, like, 3 and 5. That is, if you want to eliminate y, take the LCM of 3 and 5. Forget the negative sign, negative 5. You just take 3 and 5. The LCM will be 15. So if I perform, if I want to eliminate x, it becomes easier for me because one of the coefficients is already 6. That is equation 1, coefficient is 2. For equation 2, the coefficient of x is 6. So that happens to be the LCM. It's already there. So I just have to modify equation 1. Or if you want to eliminate y, that's also fine. But in that case, what happens? You have to multiply equation 1 by 5. You have to multiply equation 2 by 3. So you have to perform another step. So I would rather go with the elimination, where I eliminate x first. It's left to you. Again, as I said, there's no blanket rule out here. It just says elimination method. So you're free to eliminate any variable. Finally, the answer is going to be the same. Okay. So what I'll do is I'll take equation 1 and I'll multiply by 3. Why 3? Because so that I get 6x. So 2 into 3 is 6x. I'll perform that step here. See, 2 3s are 6x. 3 3s are 9y is equal to 18. Okay. So 6x plus 9y is equal to 18. That's my modified equation 1. And of course, the other equation as such, I don't do anything because already there is 6x. 6x minus 5y is 4. So that's equation 2. So now I need to perform. So I told you when there are different signs, you add them, isn't it? Plus 6x plus 6x, isn't it? So I need to eliminate x. In that case, I need to perform subtraction. Minus, this becomes plus, this becomes minus. So 6 minus 6 is 0. I will eliminated x and it's gone. 9 plus 5 is 14. Y is equal to 14. 18 minus 4. So y is equal to 14 upon 14, which is 1, isn't it? So what is it? Y is 1. So now you can go back to your equation 1 or equation 2. I'll go back to equation 1 itself. It's smaller, right? 2x plus 3y is equal to 6. And we have got y is equal to 1, isn't it? So put that y value here. 2x plus 3 into 1 is equal to 6. 2x plus 3 is equal to 6. So 2x is equal to 3 or x is equal to 3 upon 2 or 1.5. Okay. So you can always cross check, isn't it? See, if you look at the equation 2, for example, 6x, 6 into 3 by 2 minus 5y. Okay. Minus 5 into what is y? 1. So 3, so 2 ones are 2 3s are 9 minus 5 is 4. See, it satisfies the equation. So the answers are y is 1 and x is 1.5. So you might feel like solving it in any other method, elimination, we can, but provided it is elimination, you can eliminate y also, as I told you. It's only that you have to see that you eliminate y. In that case, equation 1, you multiply it by 5 to make 15y. And again, to get 15 minus 15y in the second equation, you multiply it by 3. Okay. So that you need to take care of, which you want to eliminate. You can try it out. You should get the same answer anyways. But then don't do any other method, as in don't do substitution or RCM, because it is specifically mentioned elimination. So if you go with the other method, any other method, and still get the same answer, you will not be given marks for that. Okay. So please remember that, children. All right. Now, a few things out here you should know. Like I think I told you where we'll use a square minus b square technique. Yeah. It's a plus b into a minus b. This sounds very like a rule, very rigorous, and where I'm going to apply it. But you'll actually see the usage when you actually, it sounds theoretical, I meant to say. Okay, but look at it. Take an example like 329 square minus 328 square. Now, are you going to do 329 into 329? Okay. You don't have a calculator. Remember, you have to do it manually. 328 into 320 is the exam, isn't it? In the exam, you're not going to do all this. So I'm going to do that and then perform subtraction. You have an alternative, isn't it? Let's go with that. So a square minus b square. So a plus b into the consecutive numbers, right? Squares of consecutive numbers. So that will be what? This into, what is this one? 329 minus 328. So you just basically have to add 329 and 328. 9 plus 8 is 17. 2 plus 2, 4 plus 1 is 5. Okay, no carry. 657. Okay, see, it's 657 into 1, which is 657 is the answer. You got it without even, performing any long multiplication because of the property, because of the method. So this is the application of your difference of squares. All right, and then when you can have problems like name MCQs, x plus y is equal to, let's say, 10, yeah, and x into y is equal to 24. So the question is x square, find x square plus y square. See, remember children, you remember you can, when I say x into y is 24, see all the possibilities of 24. You can say 8 into 3, 12 into 2, 6 into 4. So, but you need to look into the other condition, which is 6 plus 4, or x plus y is 10, which 6 plus 4 is 10, isn't it? This factor tree, this branch satisfies that. So you have to put, you can put x6 as x and y as 4, or anyway, it doesn't matter, isn't it? Because addition and multiplication are commutative. For this reason, you can put x is 6 or x is 4, and the y will be the other one. Okay. So then you can say 6 square plus 4 square is what? 36 plus 16, which is 52. But then this is your trial and error. Not always can you sit and factorize out things like this. So if I give you something like this, x plus y is something, x into y is something, and I ask you what is x square plus y square? So let's go with our identity. What is x plus y the whole square? X square plus y square plus 2xy, isn't it? So what is x plus y? It's given, it's 10. So you're squaring that. What's in the brackets is 10, isn't it? So x square plus y square, I don't know. I need to find out. And 2 into x into y, that's given, it's 24. 10 square is 100, is x square plus y square plus 48. So that you can say 100 minus 48 is x square plus y square, which is 52. Got it? So I think we have covered different types of problems related to your algebra part. And there's also this, you need to know some basic identities. Yeah. So just do brush up on your identities. You have learned it in 8th grade also. Yeah, grade 9 is just like especially factorization and expansion. They are I would say just an extension. You kind of recap that you do in 9th. Then coming to another question like, let's say, again, you can get an MCQ like this, a 1 marker, where I say 4y square minus, let's say, 12y plus 9. So remember, it will be in the form 2y the whole square plus 3 square minus 2 into 2y into 3. What is the form? A square minus 2ab plus b square. What is it? It's a minus b the whole square. And if it's the other way around, suppose it's a plus, simple, it would be a plus b the whole square, which will be what in this case? In case 1, it is what? 2y minus 3 the whole square. And here it is 2y plus 3 the whole square. So you should be able to identify. See, if it's a 1 marker, it's not really worth, sitting and drawing the factor tree and, breaking up the factors and splitting the middle term and all. That's not required. If it's an MCQ, the options are there. You can actually go back. You can just use the option and see if from the options if you get back the answer. Or you can understand that it's in the form a square minus 2ab plus b square. It's a basic identity. So whichever is like, easy for you. Okay. So let's move on to, okay. There's another problem, like I'll give you, this is in, we should not splitting the middle term method. Okay. So be careful, different problems on splitting the middle term method. I'll give you okay. Let's say, okay, 3x square plus 19x plus 20. Factorize, splitting the middle term it. So standard from ax square plus bx plus c. Please take the product of a and c. A into c is 3 into 20, which is 6t, isn't it? So now let's see all the possible ways we're going to get 60. Then what's a? She's right on somewhere. A is 3, c is 20, b 19. I need to get the factors. When I sum up, I need to get b, isn't it? I'm splitting up b in that manner. 10 6 are 60. 10 into 6 will not give me 19. Then 12 5 are 60. 12 and 5 will give me 17 and not 19. Then what else? Anything else? 30 into 2. 30 into 2 is 60, but 32 I'm going to get as the sum. 15 4s are, 15 plus 4 is 19. So you can use that and you can split it up as this is the right factor tree, isn't it? 3x square plus 15x plus 4x plus 20. So please, now you've split the middle term into two components. Now take these two together and these two together. Take out 3x into x plus 5 plus 4. And what's 20? It's 4 into 5, isn't it? And take out 4 common, x plus 5. So take out x plus 5 common, and you'll be left with 3x plus 4. This is the factorized version of the given expression. So you need to be very careful, and also with the signs. Here it's positive, but be careful if it's not, you have to take care of the signs as well. Okay. So I think up till here it's been clear to you. I'll share more in the next session. I think, yes, so please practice these types of problems well, because they are going to help you in your learning curve, and you should be knowing these type of problems. And again, I repeat, please remember, in MCQs, your method doesn't matter, but in all other 2 markers, 3 markers, and 4 markers, your method does matter. And go with the question. Please work out in the method that has been mentioned in the question. Otherwise, you will not be getting any marks, even if the answer is right. Okay, so please remember this. In MCQs, you just have to report the correct answer. Suppose you're solving an MCQ. All right, if I say sine of an angle, option A. Let us say this is the 5th question, for example, and I'm saying sine of an angle is always, let's say I'm going to say like it is, example is, it's always sine of an angle is greater than 1. B, I'll say is less than 1. C equal to 0. Option D, never exceeds 1. If you can recall what I told you in class, sine of an angle cannot be, these both are the same actually. So that I can put none here. For example, so sine of an angle is less than 1. Okay, even this is right, but it can also be equal to 1. Sine of an angle is equal to 0. Yes. Sine of an angle is greater than 1. No, this cannot be the right option, isn't it? So these two are the correct options, but we will not give you these type of questions where you have 2 correct answers and all. So I would be rewording it like this. Question 5, sine of an angle can never, so option A, exceed 0. Why not? It can exceed 0. Can never exceed -1. No. Can never exceed 1. Option D, can never, or you can say none. The correct option is it cannot exceed 1, because I told you your sign will always be a proper fraction like 3 by 5, 4 by 5, 7 by 10, and can never be greater than 1. As in, it can't be an improper fraction, or at the most it can be equal to 1. That's the maximum. See, for ICC grade 9 and 10, I told you we will only confine ourselves to angles which are from 0 to 90 degrees, right? Up to 90 degrees. And sine of 90 degrees is going to be equal to 1. That's the maximum that I can attain. Okay. So these kind of questions can come. And see, very careful, children. So correct option is 5 and report it as C. For the most of the MCQs, you can do it mentally. It's just concept based. You can do it quickly in the mind, and your method is not calculated, or your working is not going to seem. You can make a rough column there and work out, but it's actually the answer that I will see, 5C or 2A or 2B, whatever. So the answer matters, the option matters. So no matter you do some basic calculation somewhere and then you report it as 5A, you're going to still get 0 because you're going to see the correct option out there, not your working. Okay. All right. I hope this has been helpful to you. I'll come out with more questions in the next session.